Now we can try this one. I think these are not new thing to you. This is, we can take, this is R1, R2, this one R3 and R4. Then R T means that you know that this relationship 1 over R1, 1 over R2 plus R4. Then this is okay. This is next one. So we can draw this diagram. We can rearrange these components. From this point, we have this 8 ohm resistor. And from that point, you have 2 ohm resistor. 2 ohm resistor and this 2 ohm resistor and 8 ohm resistor, other two ends have been connected together. Like this. Now we have this wire, and from the other end, We have this 3 ohm resistor, and this 3 ohm and 11 ohm, these ends are connected together. Okay. Then after that, this 3 ohm and a 7 ohm resistors, the other terminals have been connected together. Then it's something like this. And from this side, we can take this RT. Then RT is 8 parallel 2 plus 7 parallel 3. And this is this one. And 21 divided by 10. 1.6 plus 2.1. 3.7. Find the total resistance RT and current I of the following circuit. It's a straightforward question. And RT is 1.2K, 3.3K, 5.6K, 820, 2.2K, 330 ohms, plus 4.7K. Okay, total resistance is this, and I, the circuit current, going through this direction. I equals, here the voltage is 300 volts, 300 volts divided by RT, 18.15K. Three 3.53 milliamperes. And please work out all these things, that if there is an error, then we can find it. Otherwise, that if you are copying this one, you will not find any mistakes here. Okay. The next question. For the circuit, determine the following quantities. The current of the circuit. How can we find current of the circuit? Because we don't know the total resistance of the circuit. Because of that, we can't apply Ohm's law here. Then only the clue we have received is this one. It's a 100 milliwatt voltage is there. This 1K resistor itself. Then you know that P equals VI. Okay. But we don't know I. Then we can repeat. And we don't know V also. But this V, but only the thing we have to, we know this resistance. We know this power, then we can replace this V. Then we have equation I squared R. Okay. In this case, we know P, we know R, then we can find I. Okay. It's 100 milliwatt. 0.1 watt. I squared R is 1K. Okay. The current of the circuit, the first one. The second one, the total resistance of the circuit. You know the current now. Okay. Second, you can find voltage is 130 volts equals 0.1 into RT. Third one, the total power delivered by the battery. W equals VI. We know it's 130 volts. and current is it's 1.3 watts. Okay, fourth one, the value of R. Now we know the total resistance. Total resistance is 13K. RT equals if we put this is R1, R2, R3 like that. Plus R, this is 3K, 4K plus 1K plus R, and this is 13K, then R equals 5K. Okay. The sixth one, the dissipation of each resistor. Alright. Fifth one, the voltage drop across each resistor. Okay. The fifth one, voltage drops. Then we can take VR1. VR1 is R1 is 3K. Current is 0.1 ampere. It's 30 volts. Then VR2, it's 4K into 0.01 amperes. It's 40 volts. 3. 1K into 10 volts. Then VR resistance is 5K. 5K into 0.01 ampere. 50 volts. Okay. Power dissipation of each resistor. Okay, next one, the power consumption of each resistor. 6 WR1, W means voltage, is 30 volts into 0.01 amperes. 0.3 watts. WR2, 40 volts into 0.4 watts. VR3, 10 volts into ampere, 0.1 voltage. And VR, this is 50 volts into 0.5 watt. The last one, to find the energy, amount of energy, if it is powered for 18 hours. Now here total power is how much? 1.3 watt. Okay. Check energy, total wattage, 1.3 watt. 1.3 watt, and for 18 hours. Clear that 19.45 watt hours.
Excuse me, sir.
Yes.
It's 23.4 watt hours.
Okay. 0.3. Yes. Thank you. 23.4 watt hours. Then we can convert this one into joules. Then it's 23.4 into 60 joules. Okay. Okay, now we can try these ones. Okay, shall we try these things using Thevenin's theorem? Okay, what we have to do first, we have to identify the component to be removed. Okay, it's very clear that we have to calculate the current going through this RL resistor. Then this is the component we have to remove. Okay, then these 2 points. Shall we redraw the circuit? R1. This is point A. Point B. R140, 50 volts this one. This is 10 ohm. R2. This is 12 ohm. Okay. Now we are going to find Thevenin equivalent circuit for this part of the circuit. Okay. Then you have to find RTH. To find RTH, what we have to do, we have to short circuit this current source, sorry, voltage source, and redraw the circuit. Okay. Okay, then we can remove this one because Then you have to look at from this side, find RTH. Then RTH is 40, 10, they are parallel, and it should be added to the 12 ohm resistor. Okay, then this is 40 into 10. This is 40 plus 10 plus 12. Then this is 400 divided by 50 plus 12. This is 8 plus 12, 20 ohms. Okay. Then we have to find Thevenin voltage here. Then we can find VTH. To find VTH, what we want to do, we have to find open circuit voltage across this point VAB, that is VTH. Okay. Then you should understand one thing here. The current going through this direction is 0. Because of that, there is no voltage drop across this resistor. Then if you find voltage across these 2 points, okay, these 2 points, that is VAB. That is VAB. Okay. Then we shall mark this current as I. And we can find I 50 volts into 40 into I. That current should go through R2 also. Okay. So the current is not going through R3. Then plus 10 ohm into I. I is 1 ampere. Okay, if I is 1 ampere, actually we don't want to do this. Say also we can apply voltage divider rule also. Then this VAB is 10 volts. VAB is 10 volts. Okay. Then VAB is 10 volts means that is VTH. Then we can draw the Thevenin's equivalent circuit. This is RTH. It's 20 ohms. And this is Thevenin voltage. This is point B. This is point A. Thevenin voltage is here 10 volts. Now we can add our removed component here. Then we can find IL. Okay. The removed component value is 30 ohm resistor. ohms. L, then IL equals 10 volts divided by 20 ohms plus 30 ohms, then 10 divided by 50, then it's 0.2 amperes. Okay. This one, this question we have current source. Again, this is the component we have to remove. And this is the point A and B. Then shall we draw the circuit, this one? This point B. Here we have 90 ohm resistor. And this current source. This is 30 ohm. Okay. Then we have to find RTH. To find RTH, we can draw this. We have to open circuit this one. We can remove this. Okay. Point A. This is 90 ohm. This is 30 ohm. When you look at from this side, you can find this one. Here we have removed the current source. There is no one there. Then RTH is 90 plus 30, 120 ohms. Okay. Shall we find VTH? Okay. This is 30, 90, and 40 milliampere. Then we want to find this VAB. Why? It's equals to VTH. Okay. Then shall we mark current here? I is 40 milliamperes. It's coming from this one, and this current is 0. Because of that, voltage drop. Because this one is V is 0, then VAB is the voltage across 90 ohm resistance. Then we can find it like this. VAB, the current going through this resistor is 40 milliamperes. and resistance is 90 ohms. Six zero zero, then it's 3.6 volts. Okay. Now we know VAB, that is VTH. And now we can draw the circuit with Thevenin resistor. Thevenin resistance is 120 ohms. The voltage source 3.6 volts. Okay. Now we can add the remote component here. The value is 60 ohm. This is the current we want to find. IL equals 3.6 volts divided by 20 ohms plus 60 ohms. 3.6 divided by 180. Okay. Okay, this question here, actually we have to identify the component. And this is the one we are going to remove because this is the current we want to find. Then we can draw the circuit. This 1K, this 8 volts, 6.8K, 1.2. And this is point A, this is point B. Okay. And then we have to find RTH. To find it, we can We draw the diagram removing the voltage source. This is point A, point B, and this is 6.8K, 1.2K, and this one is 1K. Okay. Then you have to look at it from this side to find RTH. Actually, RTH equals to 1K plus 6.8K into 120K. So this is RTH. Now we have to find VTH next. This is 6.8K, this is 1.2K. Now we want to find this VAB. Okay. But here you know that the current is not going through this resistor. Only the way current has to go is this one. Here, through this one, current is not going. Because of that, actually, there is no voltage drop here. And there is no current here. And if you find the voltage across these 2 points, this point and this point, that is VAB. But instead of that one, that if you find voltage across this resistor, 1.2K resistor, that is also VAB. Okay. Then if you find this voltage You can apply voltage divider rule also, doesn't matter. Find this one, then VAB. Then this VAB, we are expecting in this direction, but the actual current is going through this one, then this voltage is appearing this direction, V. Okay, then VAB is minus V. It's equals to minus 8 volts times 1.2 K divided by 16.8 K plus 1.2 minus minus 1.2 volts. So the reason we are getting minus is that actually the point A is here, but we are bringing point A here. Then VAB we are expecting in this direction, A should be, but here the current is going through this direction. Then this B is appearing this way, because 1.2 K voltage is in this direction, but VAB is in the other direction. Okay, now we can draw the Thevenin equivalent circuit. This one resistance is 2.0. B, this is minus 1.2 volts. We can introduce our removed component here. It's 1.5 K. Okay, and we can find load current. IL equals minus 1.2 volts divided by 2.02 K plus 1.5 K. We can take 8K resistor. Where is that 8K resistor? Here in our original diagram, we don't have 8K resistor. Can we take VAB across the 8K resistor? This question is asked that we don't have 8K resistor here. When in equivalent circuit, So it should be minus 0.34 because the voltage is minus 1.2. 6.8 K resistor. But if you take the voltage across 6.8 K resistor, it's a part of VAB. Because if you find this one here, across this one we have one voltage this way, and here also we have this voltage this way. Okay, and if you take the voltage across the 6.8 K only, that is wrong because we want to find the voltage across VAB. But if you take 1.2 K resistor, that is VAB. Okay. This one. And this is the component we are going to remove. And now we can redo the circuit. This is point A. And this is B. Here you have 50K resistor. This one is 20K resistor. And the current source, this one, is 100 microamperes. Okay. Then shall we try to find VTH? Sorry, RTH. In this process that we are going to find VTH. This one RTH. To find RTH, we have to open circuit this one. Then only the resistors are available here. $20K. $50K, this one only. Then we have to look at from this side to find RTH. Then this RTH is 20K plus 50K, that is 70K. Okay. Then next thing we have to find the VTH. VTH is voltage across VAB. Okay, sorry. And if you find voltage across this 50K resistor, that is VAB. Okay. But this current is going the other way. Because of that, if you find this V across this resistor, then actually VAB is minus V. Okay. This minus V equals 50K into 100 microamperes. Then microampere is 10 to the power minus 6. Then here it's 10 to the power minus 3. Then this will be cancelled out, and then this should be 5 volts, minus 5 volts. Okay. Then we can draw Thevenin's equivalent circuit. And this is minus 5 volts. RPF is 70, and then 8. This is 70K. The removed one is 180K. Okay. And we can find current through it, that is IL. IL equals minus 5 volts divided by
Excuse me, sir.
yes.
Sir, should that be minus 5K volts or just 5 volts?
Okay. Here it's minus 6. This one.
Yes, sir.
Actually, this is 5 into 10 to the power 3. This is 100 into 10 to the power minus 6. Then, sorry, it's 50. Okay. Then finally you have 5 into, here you have 10 to the power 3 and another 3. This is 6. Then this will be cancelled out. Is it okay?
Yes. Okay, sir. Thank you, sir.
Okay. Then IL is this one. Okay, the last question. This one. Okay, this is the component we have to remove. It's 20 ohms and 50 ohms, two resistors there. Two resistances are there. In two occasions, we have to calculate IL. Okay, anyway, that we can redraw the circuit. This is point A. And here we have current source, 0.2 amperes, 16 ohms. Point B. 2.4 volts. Okay, this is 24 ohms resistance. Okay. Let's try to find RTH. To find RTH, we have to redraw the circuit, removing this current source and short circuiting this voltage source. This is point A. B. This voltage source should be short circuited and this current source should be removed. And this is 24 ohm resistor and this is 16 ohm resistor. We have to look at it from this side to find RTH. Okay. Then RTH is this is a conductor. Conductor parallel with another resistor. Then current will not choose this path. Then effect from this 24 ohm resistor is 0. Then the final resistance of this RTH is only this 16 ohm resistance. Okay. Okay, we can draw the circuit now. This point A. Because we don't take the other resistor, but here, when you come here to find the total resistance of this one, then this here we have conductor, here we have resistor. Then we have to conduct, you can see that these two are parallel. When the current sees that there are two paths to go, and then this is conductor, there is no resistance here, and there is a resistance here. The current will select definitely this one. Okay. At the other way also you can apply this is a 0 ohm resistor, and this is 24 ohm resistor. And you can do the parallel calculation, and the result of this is 0. Then it's a only 16 ohm resistor. And we have to find voltage across these 2 points, that is VAB. Then we don't know the resistance or something of this one, but if you find this voltage, we know that this is 2.4 volts, and the voltage here, this one, that is VAB. And this is V1, V2, VAB is V1 plus V2. Okay. The current going through this one is, this is 0.2 ampere. It's going this way. This is 0.2 amperes. Then we can find the voltage across this 16 ohm resistor. That is V2. You can consider this one as V2. Okay. Then VAB, V1 is 2.4 volts, and V2, this is 2.4 volts. V2 is 16 ohm into 0.2 amperes. 2.4 volts. It's 3.2 volts. Then it's 5.6 volts. Now we can draw a Thevenin equivalent circuit. This is point A, and this is 16 ohms. Point B, and this one is 5.6 volts. And we can bring here the remote component. It's 20 ohm, 50 ohm. It's RL. And we can include it here. This is IL. Okay, we can consider 2 occasions when RL equals 20 ohms. Then IL is 5.6 volts divided by 16 ohms plus 20 ohms. Sorry, 36. It's 0.16 amperes. Then RL is 50 ohms. Yes. This is IL. .6 volts, 16 ohms into 50 ohms. Is it okay? Anything? Any question?
Excuse me, sir. Can you please show the answer for the first question? Sir, there when we take the multiple, is it 9.52?
Which one? This one?
First one, yes.
Here, you can check these calculations. It's a 1 over 27, and I put these things, and this is 1 over RT. Then I have taken the reciprocal of this 0.105.
Sir, can we take the common term and then multiply the rest by the...
It doesn't matter. Common terms means
Okay,
here
sir.
you are going to take the common term here.
Yes, 27 into 33 into request by multiplying, can't we take the answer?
Then how can you put this one here? 27
What?
multiplied by 33, 56, and what about this one? Here, for these ones, what you are going to put?
Then except the denominator, we can multiply
All other
them by
values.
other. No? Yes.
Yeah, that's also possible. But I think that you can, you are allowed to use calculators also.
Yes, sir.
Yes, then without wasting time, just try it this way and do it by using a calculator.
Okay, sir.
Sometimes there may be a mistake in my case also, but check it. Values may be wrong, but you can use this method.
Okay, sir. Thank you, sir. So in the second one, isn't the circuit all the, I mean, not the one before this one.
This one.
Is there, yes, sir. There resistance, aren't the resistance, all the resistance are parallel?
No, here that when you take this point, And these two resistors are starting those 2 points. And the other end of those two resistors have been connected by using this wire. Okay. So simple that you can bring this point here. Then meaning is 8 ohms and 2 ohms, these two resistors are parallel. Okay. And when you start from this end, 3 ohm and 7 ohm resistors are starting from same point and ending in another same point. Then 3 ohm, 7 ohm resistors they are separately parallel. But these two sets are combined by a single wire, then they are series.
So then when we are given a circuit like this, we have to first draw it separately, no? Then we can do the
I
calculation.
think it's good that if you rearrange
Okay,
the things, then it's good. Then you can look at it very clear view. You can have a very clear view there.
Okay, sir. Thank you, sir.
Okay, welcome. Do we have any other question? Okay, go ahead with the question, then we can finish the lecture now. I think we haven't seen so far. Maybe you can follow you can check the previous question papers, the same format of question we received this year also. I think it's a one complete question. Half of the question is based on the Thevenin's theorem. The other half will be covered by the basic things that we have discussed so far. The same format you will be received this year also. I have uploaded all the videos and I sent these links to the URA, your teaching coordinator, and he will share all these links with you. And this video also, I'll with the weekday group, I didn't put any video for this tutorial. I'll put this one also, and all the relevant this course notes. Actually, this is not a complete note because that I have mentioned several things, and in support that one, I have drawn certain things on the document. These Word documents, and I have converted into PDF, and those things also I have sent to your teaching assistant, and he will share this one with you. You can refer all these things, and you have my mail address or the telephone number, whatever thing. Then you can, if you have any question, you can contact me also. And thank you very much for your cooperation during these 5 days. And anyway, that we haven't seen each other. Hope you that you will do your examination well. And thank you very much for your participation and your cooperation. And wish you all the success at your examination. Thank you very much.
Thank you, sir.
Thank you,
Thank
sir.
you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.